Let's solve some more problems by finding equivalent ratios. The Business District Hotel caters to different types of people that are going on business trips. And on Saturday nights, there isn't a lot of business travel. So much so that on Saturdays, the ratio of occupied rooms, occupied meaning a room that has someone in it, versus unoccupied rooms, rooms that have no one in them, is 2 to 5. However, on Sundays, the ratio of occupied rooms to unoccupied rooms is 6 to 1. For every 6 occupied rooms, there is 1 that is unoccupied. So, if this business hotel has 432 occupied rooms on Sunday night, can we find the number of unoccupied rooms on a Saturday night? Okay, let's make a table. We know we're dealing with Saturday and Sunday, so let's label that. We also know that on each day we're dealing with occupied and unoccupied rooms, so let's put those labels down as well. And we are told that on Saturdays the ratio of occupied to unoccupied is 2 to 5, and that for Sundays the ratio is 6 occupied rooms to every 1 unoccupied room. The last bit of information we are given is that on Sunday there was a total of 432 occupied rooms. Now this is great, because if the total of those 6 units is 432, then we can simply dump that 432 into all of those units equally and find that each unit is worth 72. And this helps us greatly, because now we simply need to plug 72 in for all the other units. And because both Saturday and Sunday have a total of 7 units, it's fine to dump 72 into each of those units. When we're done with that, we can find our totals by adding or multiplying, and we learn that unoccupied rooms on Saturday, there are 360. Okay, let's talk about a guy named Peter. He's trying to gain muscle, so he's doing sit-ups and push-ups. Previously, Peter was doing 5 sit-ups to every 3 push-ups. And so his ratio of sit-ups to push-ups was 5 to 3. But, oh, poor Peter. He hurt his shoulder. And so now, his exercise ratio is 7 sit-ups for every 1 push-up. The ratio being 7 sit-ups to 1 push-up. During a training session after his injury, Peter completes 8 push-ups. If that's the case, then how many push-ups was Peter completing before his injury? Alright, we have pre-injury and post-injury, so let's label the table. We also are dealing with sit-ups and push-ups, so we can label those. And we know that before his injury, he was doing 5 sit-ups to every 3 push-ups. We also know that after the injury, he is doing 7 sit-ups to every 1 push-up, so we can enter that data as well. The last bit of information we're given is that after his injury, he was able to do 8 push-ups. Now this makes our problem simple, because that 1 unit is worth 8, which tells us that all the other units are worth 8 on his post-injury side. This also means that all units on the pre-injury side are 8 as well, because it also has a total of 8 units. Now, because we know all the unit values, we can combine them to find totals. And now we know that before his injury, Peter was doing 40 sit-ups and 24 push-ups, and after his injury, he was doing 56 sit-ups and 8 push-ups. So then let's answer the question, how many push-ups was Peter completing before his injury? Let's see, before his injury, that's pre-injury and push-ups. There it is, 24. Peter was completing 24 push-ups before his injury. Alright, let's talk about a bike store. This store often orders both bikes and scooters. It was previously placing orders for every 3 bikes, it would order 4 scooters, with a ratio of 3 bikes to every 4 scooters. But the store has recently learned that people actually prefer bikes to scooters and has changed its order. The new orders of this shop are for every 5 bikes it orders, it will also place an order for 2 scooters, for a ratio of 5 bikes to every 2 scooters. Now, if 64 scooters were originally ordered, how many bikes were ordered as part of the new order? Okay, what are we dealing with? Well, we have an old order and we have a new order, and we have bikes and we have scooters. And we are told that the old order was for every 3 bikes there were 4 scooters, and the new order is for every 5 bikes there are 2 scooters. Notice that both the old order and new order have a total of 7 units. The last bit of information we are given is that the old order consisted of 64 scooters. Now, because we know that there are 4 units and the total is 64, we were able to take 64 and dump it in evenly into all those units, seeing that each unit is worth 16. And that helps us out for the rest because we now know that every other unit is worth 16. And because both the old order and new order had a complete total of 8 units each, that 16 per unit is the same in both. Now to find the totals of the rest of the orders, we combine and see that there are 48 bikes and 64 scooters of the old order, and 80 bikes and 32 scooters of the new. And again, the question was, if 64 scooters were originally ordered, how many bikes were ordered in the new order? Let's take a look again at our data. So yes, 64 scooters were originally ordered, and how many bikes are part of the new order? 80. 80 bikes are now part of the new order.